I am at your beck and call. I will work through anything off the review that you guys want to see.
Oh my god, it's tomorrow.
Test is tomorrow.
Jesus Christ.
I will tell you the ones that I already did on my video for third period if you want to know. I went over number 1, number 2, number 4, and number 5, part B. Those are the ones that I already have on video that I will be posting as soon as school is over today. I'm happy to go through any of those again if you want, or if you want to see different problems and you want to watch the video for any of those that you have questions about. Again, I am at your service right now.
Wait, can we see? Hold on, can you say which ones you have videos on the surface?
Yep, there's a video over number 1, number 2, number 4, and 5 part B.
Okay. Can we do number 6?
Number 6, absolutely.
Yeah.
Yes. Okay. Says solve the following equations with whatever method you choose. In order to solve, no matter what method I choose, it has to be equal to what?
0.
Has to be equal to 0. So on this first one, the only way I can get this equal to 0 is if I distribute everything over on the right-hand side, and then I add 9. So that means first we're going to double distribute the binomials, and only after we have double distributed there will we distribute that negative 1/2. So I'm going to distribute the x to both pieces. That would give me x squared minus 1x. I'm going to distribute the 3 to both pieces, so plus 3x minus 3. I'm going to combine my like terms together. What do I get when I combine my like terms? X squared plus 2x minus 3. I don't really want to distribute a 1/2 because that's going to give me some decimals in there. There's another way I can get rid of that 1/2.
Can you add it?
I can't add it because it's being multiplied right now.
Multiply by 2. Or is that
Multiply by 2.
Oh, you said you didn't want to divide it.
Yeah. Let's multiply by 2. Are you guys okay if we multiply by negative 2?
Yeah.
Yeah, because if you do it to one side, it's valid as long as I do the exact same thing to the other side. That's going to cancel this out, and it will leave me just that part inside the brackets.
So why did you multiply it with negative 2?
So that I can make it cancel. Whatever's down on the denominator, if you multiply by that, it'll make your fraction cancel. You would only be left with your numerator. In this case, the numerator is a 1, so we're good. And a negative times a negative gives me the positive. It's going to allow me to avoid having decimals at this point. So I'd have a positive 18 equals x squared plus 2x minus 3. I can add 3 to both sides, but since I want to solve this quadratic, I need it equal to what?
Subtract 18.
Yeah, let's subtract 18 from both sides because I need it equal to 0. All right, 0 equals x squared plus 2x minus 21. We've got a couple choices at this point. We have 3 algebraic solving methods. We can complete the square and solve it that way. We can try to factor it, or we can use quadratic formula.
Wait, what are the options? Factor, quadratic formula, and what?
Completing the square and solving it that way.
Isn't that the same? Can we do factored and quadratic? Because I feel like we've practiced a lot
On the other one?
Are we doing the whole 6 or just 6A?
I'm going to do the whole thing.
Okay, so on this one, could we try each different method on each
Yeah.
one? Okay, then can we just pick one? Does that make sense?
Yeah, let's try, you said you want to try factoring on this one?
Yeah, yeah, but like
Okay.
the others we can do like square and the other.
So let's look at this one. So I would need two numbers that multiply to give me what? Negative 21, but add to 2.
Yeah. This would be like 7
Let's see, 7 and 3.
It's but it wouldn't subtract to 4, so to give you 2.
So that's not going to work. What else multiplies to 21? 1 and 21. That one's not going to work either. Does this one factor?
No.
So we can't practice factoring on this one because it doesn't factor. We can do quadratic formula, absolutely. So let's use quadratic formula on this one, and we'll try factoring on another one. So if I'm going to use quadratic formula, I need A, B, and C.
Well, how'd you do that?
Oh, I can lasso things and shrink them. What value are we going to use for A?
X squared.
What's in front of the x squared? 1. Because remember, in quadratic formula, we only substitute in numbers. What are we going to use for B?
2.
2. And for C?
Negative 21.
Negative 21. All right, I'm going to write quadratic formula down up at the top. I will give you quadratic formula and all 3 of the forms on the test tomorrow. It'll be up at the top of every single page. All right. All right, so I have x equals, you're welcome, negative, and then I'm going to substitute in for b. I always use parentheses around my substituting when I'm doing quadratic formula work because it keeps me from making mistakes with my signs. So I have negative, and then we're going to put what in for b? 2. Plus or minus the square root of b squared. Yep, so I have 2 squared minus 4 times, you said what? 1 times negative 21.
2 times A.
And 2 times a. What is our a value?
1.
Yep. Takes a little bit longer to write it all out, but it will save you trouble. All right, I'm going to clear out some space at the bottom here so that I can write down here. We do need to simplify it, yes. I'm going to use my space right here. Haha.
Can we add paper?
Can you add paper to it? Absolutely. Do you want some scratch paper? Yeah. Yeah, you can submit it virtually if you want to.
Because I just forgot to turn it.
Okay. So when I simplify that first set of parentheses, when I have negative 2, that just simplifies to what? Right here. Yeah, that's just going to be a negative 2. Plus or minus, I'll deal with that radical in just a moment. Down on the bottom, what does that simplify to? 2. All right, I'm going to grab all of this right here, and I'm going to do it off to the side. So I have 2 squared minus 4 times 1 times negative 21. What's 2 squared?
4.
4. Make some more space here. So I have 4 minus 4 times 1 times negative 21. I multiply the 4 and the 1 together. So I have 4 minus 4 times negative 21. Make sure you follow order of operations. If you do these together in more than, like, you don't take as many steps, that's fine. I just want to make sure that we understand along the way where everything is coming from. Because right here, I usually see a big mistake happen. What do you think people forget? Negative times a negative is going to give us a positive. A lot of times people will forget, and they'll have 4 minus 84, and they'll get a negative and say, I can't go any further, because I tried to do the square root of negative 80 on my calculator, and it said it couldn't do it. This is supposed to be 88. Can the calculator do a square root of 88? Yes. So that goes underneath the radical. Kyla, what questions do you have, dear? Okay. You looked like you had a question. I am almost ready to grab my calculator. There's only one issue. 2 different, yes. What are the 2 different things that we're going to put into the calculator? Yes. Negative 2 plus the square root of 88 over 2. And we'll do the exact same thing, but where it's negative 2 minus the square root of 88 over 2. I want the decimal approximation, so on these yellow calculators, it's still going to spit it back to you in exact form. You'll hit, after it gives you the answer in exact form, so still with a radical in it, you'll push the button right above the enter key. It's got arrows that point left and right. That will change it into a decimal for you.
Is that negative 9.38?
It is not negative 9.38. Let me see what we put in.
Oh, wait.
So you need to type it in exactly like this.
If you just look at this, you probably forgot the plus stuff.
You guys have a fraction key on these yellow calculators. You can put this in as a fraction.
3.69.
3.69 is what you get for the one when you add. Yep, 3.69 for the one where you add. What do you get for the one where you subtract? Negative 5.69.
I did that, and then I did
What do you use?
You trying to learn too? I know.
Well, yeah, sorry.
What do you mean?
Like for your notes.
A program called Doceri.
I'm not
Is it
interested.
free?
This right, Taylor trying to learn too. So this is where I got so far, and I don't know how to divide it to get the 2 again.
Where's your plus sign?
But it was something.
Oh, it's not automatically gonna add because it's.
If you put them side by side, what is your calculator going to do to them?
negative,
It's going to multiply it. You don't want it to multiply, you want it to add.
so plus.
So negative 2 plus the square root of 88. Yep, then hit enter. And now you're going to divide it by 2 because you've got to divide it by your
So I
denominator.
can't put the thing in there's not gonna be a divide sign here. I have to do it all separately.
If you want to put it in all at once, you have to put the numerator all inside parentheses and then divide by 2.
Okay. Oh, thank you.
You're welcome. Yes, ma'am.
I was like, sorry, I missed it.
Because it's raining.
I just want ice
I know, right? Very summer. Very summer. Because it's almost like May, right? And then we have like what, 2 months for summer?
So we want. Oh wait.
Right.
Let me check that on the answer key because yeah, it should be like this.
No.
I'll check that. All right. Are you guys okay with part A?
Yes, ma'am.
Yes, sir. Huh? Grab a different outlet then. I don't know what's going on with it. Or there's one right back there. Part B. You guys said you wanted to try a different method on each of these. Let's try to factor this one.
Yeah, because this one
What's this one equal to?
2. Well, 0. Why?
Right now it's equal to y, but we want it equal to 0. We can just put a 0 in there. If there's a number there, then we have to deal with that. But if there's no number there, we can pop a 0 in. When we decide to solve by factoring, what do you have to look for?
The common.
Greatest common factor.
Greatest common factor. Do we have one?
Yes.
What is it? 2. Let's get it out of there. Divide everybody by 2. So I'd have 2 times x squared minus 2x minus 3. And then I need to do my x. I need 2 numbers that multiply to give me what? Negative 3, but add 2. What will do that? Negative 3 and 1. So I'm going to do my area model. A value always goes here. C always goes here. So I have x squared and negative 3. Those 2 numbers that we found, they have to have x's back on them because remember, together, these 2 are my b value. Here's my a. These 2 together are b, that's c. This is just another way of writing what I have right here. What can I take out of x squared and negative 3x? I can take an x out here. What about here?
1.
1, positive or negative?
Negative. Positive.
Positive. It's touching a box that's positive, so I take that sign out. What about this way?
X.
X
And negative 3.
and negative 3. So I have 0 equals 2 times x plus 1 times x minus 3.
And then you said each part is equal to 0.
Each part equal to 0. Each factor. How many factors do we have?
2.
3 factors. Yeah. The F in GCF stands for what?
Common
Factor?
Factor. So I take that and set it equal to 0 also.
So that would be 0.
Hold on. Give me just a second. Let me get this out of the way. I'm running out of room here. All right. Does 2 equal 0? No. Is there an x to solve for here? Nope. Throw it out. Doesn't make sense. If x had been part of my GCF, and so I'd pulled an x out with everything, then I would have an x to solve for. It does count as a factor. That's one that often gets missed. And so when we have x as part of our GCF, a lot of times we'll miss one of the roots. That's why I wanted to draw attention to that. Anything within x in it, you have to set equal to 0.
So it's just 2 equals 0.
Hmm?
Or the
2 equals 0, but 2 doesn't equal 0. So we're just
Oh, 'cause
throwing it
it's
out.
making it equal to 0.
Yep. Yep.
So the answer would be like x equals negative 1 and x equals 3.
Yes. X equals negative 1. X equals 3.
The reason why you did factor out on this problem because you could find a GCF for the not for all the time.
This one we chose to factor. There was a GCF, and then when we did this, we're like, oh, I found those 2 numbers.
But if you're not able to find those 2 numbers, that's when you move on to moving the larger problem.
Yep. Yeah, over there we tried to solve by factoring. It didn't factor, so quadratic formula it was. Part C.
Wait, so that's it?
That's it. We are done. Put a circle around that one. This one over here, I want to solve it, so it needs to be equal to
0.
0. All right. You said you wanted to try all the methods here. We did quadratic formula. We did factoring. So let's solve this one using completing the square, which it already has the square completed. We just need to get the x all by itself. We're going to go backwards through the order of operations because that's how we solve. Simplifying is when you go from the top down. Solving means going from the bottom up. When will I be allowed to get inside these parentheses?
After you have divided,
After we've divided and after
then the exponent.
the exponent. I won't be able to get into the parentheses until way up here. The entire time I'm doing this, though, I'm staying on this side, and I'm trying to figure out how to get rid of this stuff.
So why don't you do parentheses first?
Because we're solving. Solving is going this way, always.
So solving, okay. So
Yep.
then you add 3 to the other side. Is it, or does it still
Well, if I add 3 to both
does
sides,
it need, subtract?
subtract
Does it
3.
need- It doesn't need it, because it doesn't need to be equal to 0.
We put in a 0 right here.
Like, but it doesn't.
It doesn't need to stay equal to 0. Yes, it does not need to stay equal to 0. So I'm going to subtract 3 from both sides. Yeah, when we're using this method, we don't want it to stay equal to 0. So I'm going to have negative 3 equals negative 3 times x minus 4 squared. You said do what next?
Negative 3 divided both sides by negative 3.
Yes. We're going to divide out that leading coefficient. What is negative 3 divided by negative 3? So I have 1 equals x minus 4 squared.
And then you square root that.
When we square root, we get how many answers?
2.
2 answers. So we're going to take a square root of both sides. So I have plus or minus the square root of, what is the square root of 1?
1.
So this is just plus or minus 1 equals x minus 4. Why did I drop the parentheses?
Because you cancel that with the exponent.
I canceled out the exponent, so I didn't need them anymore. There was nothing else over there.
Then you add 4.
Add 4 to both sides.
So it'll be 1 plus 4. So it'll be 5 and then 1 minus 4.
Mm-hmm.
So, so x equals 5 and x equals negative 3.
Close.
Positive.
Positive 3.
What? So you dropped the exponent on the
bigger number is positive.
x minus 4 because you had a square, but you kept the plus and
But
minus.
isn't it 1 minus 4?
See, like the way.
So whenever you take a square root as part of solving, you're trying to figure out what number times itself would give me this. Well, 1 times 1 gives me that, but negative 1 times negative 1 also gives me that. There's 2 possibilities. It's always going to be 2 possibilities when we take a square
So
root.
that's why you dropped the square root on the 1 and kept the plus and minus because it'll always be itself.
Well, it's not always going to be itself. It's always going to be plus or minus. If I had the square root of 2, it wouldn't be plus or minus 2. It would have to stay plus or minus the square root of 2.
Why can't you put the 1 first?
You can, but it would be positive 1 plus 4 and negative 1 plus 4. You're still adding the 4 either way.
That's why I was confused as to why it was.
Yeah, you're not plussing and minusing the 4.
Yeah.
You're plussing and minusing the 1.
Yeah.
All right.
It's like the middle. Doesn't matter.
Yep, I'll leave it right here.
Yeah. Okay. Like this. Whatever the middle part is, that's the exponent.
Mm-hmm. Thank you, ma'am.
What you gonna know? This
Uh-huh.
this is the axis of symmetry, right?
Yes.
So this would be 5, right?
Yep, and then you need to tell me, because it has to be the equation of a line. So what axis did you go through when you drew that line with your finger? The x-axis.
Because
So
I
it's
think-
x equals 5.
Because I think on the review it says 5. It says 3. That's why I changed it. But it's actually 5, and I was doing it at home.
Yeah, let me double check, because that's the second mistake that I've heard of. I'll get in and double check.
Yeah. I wrote first 5, but then when I went and I was doing the review, it says 3. I was confused.
like to see? We've gone all the way to number 6.
Which one is the hardest one to think we should go with?
Hardest one. Here's one that we have not gone over in a minute.
Yes.
This guy right here. Says solve both algebraically and by graphing. Anything that's on the review is fair game for the test. Anything that's on the review is fair game for the test. Which part do you want to start with? Algebraic or graphing? Graphing, okay. What shape is this going to be? A U. This is a parabola.
And the other one is a straight line, right?
The other one is a straight line. So for my parabola, I want to make a table so that I can get a couple of points. I need the vertex. How can I find the vertex? Put it in vertex form.
So you want to do this algebraic first, so change your top.
No, we can do it like this. It's in vertex form.
Oh, so is it just 0, 3?
0, 3. Our vertex is 0, 3. How else could you have found that if you weren't sure that 0 was the x part of the vertex? Negative b over 2a will find the x part of the vertex. That's not it. That's what we're going to use. And then you look at A, B, and C. What's your B value here?
3.
No, that's C. 0. That's why the vertex has 0 in the x column. And then we take that 0, you substitute it in the place of x to find what your y is.
Oh, so the line one, it'll be like 2, 6.
Yep. So once I have, shh, ladies. Once I have the vertex, I want to pick a couple points on either side. So what's to the left of 0 on the number line?
Negative numbers.
Negative numbers. Give me a couple.
Negative 2.
Negative 2.
Negative 4.
Negative 4. We could do that.
Negative 6.
Well, that's probably going to fall off my graph.
1. Negative 1.
Let's try negative 1. So if I put negative 4 in, what is negative 4 squared?
16.
16 plus 3?
So 19.
19. Not going to be able to graph that one. It's too big.
How do you know that?
Because the graph only goes to 10.
Oh.
If I take negative 2 and put it in, what's negative 2 squared? 4 plus 3? 7. That one's going to fit on my graph. Negative 2, 7. I'm going to put negative 1 in. What is negative 1 squared? 1 plus 3?
4.
So negative 1, 4. I'm starting to see this shape. What else should I do? 1 and 2. I need some positive numbers because I need some numbers over on the right.
It'll be the same answers.
Yeah.
You just mirror it?
Yep, that's exactly what's going to happen. It's going to mirror on the other side, so it's going to be 4 and 7 again. Can you verify that by putting it into your calculator to make sure?
Yep.
Yep. Yep. Am I in the way?
1.
All right, so there's my parabola. Going to graph this line, what information do I need? I need slope. What is our slope? 2 over 1. We're going to have rise over run. And what is our y-intercept? 0, 6. So I'm going to graph that first. Rise over run means I go up 2 and run which way?
Right.
Right. up 2, right 1, up 2, right 1. Make it go backwards. And then I'm going to use a straight edge to draw this line in.
Oh.
Where would I be looking for solutions? Where they intersect each other. How many places are they going to intersect? 2 places. One of them I can see clearly right here. Where's the other solution happening? It's off the graph. Somewhere up here is my other solution. Now we're going to do this algebraically. One of them, I'm pretty sure I can see that ordered pair. What does one of them look like? Negative 1, 4. That's really useful because since that's a whole number for the x, I know this is going to factor when I set them equal. To solve algebraically, you have to set them equal. So I'm going to have x squared plus 3 equals 2x plus 6. But since I'm solving algebraically, after I set them equal, I need it to be equal to what now? I need it to be equal to 0. Yes, ma'am. Well, I want numbers so that I can graph them. So I want the outputs to fall in between here and here. So that's why when we put the negative 4 in and we saw 19 as an output, if you're all finished, you can put it on my desk. If you're not finished, are you all finished, Michelle? Okay, wonderful. 19, that's way up here. I can't put that on my graph. So we had to pick smaller x's so that it would be on the graph.
Okay, so but I could pick like -3 and that would still be fine.
Yeah, as long as it falls on your graph. Yep.
So you could have just.
We're going to set it equal to 0, so I'm subtracting 2x and 6 from both sides. X squared. I can't combine the 2x with the x squared. Can I combine the 3 and negative 6? Yeah.
So why are you combining instead of just subtracting the 3 and getting the x squared by itself so you can do a square root?
Because I still have an x. I can't do a square root of this.
No, like the Xbox. Yeah, I don't know how to explain it. Like you see, if I just subtract 3 like this, boom, that would be x squared, and then I have 2x, and then it'd be like -3, and I could just do something like that. You follow what I'm saying?
What's the square root of 2x?
They don't have to square root?
We don't know what it is because we
So
don't know
I
what
can't
x
do that?
is.
So-
Correct. You need all your x's on the same side.
Okay, thank you.
You're welcome. Can we try factoring this?
Yeah.
Yes. In fact, because of what we could see up there, I already know one of the 2 numbers. What is one of the x's going to be? -1. Well, that's an answer, so it'd be opposite 1 and -3. We did an x box for this already, but I'll go ahead and do it again. A and C. So I have x squared here, -3 here, 1x, -3x. I get x plus 1, x minus 3. We take our factors and set them equal to 0. X minus 1 equals 0, x plus 3, sorry, minus, that. Yes, Lauren?
Where did you get the -3 from?
We combined +3 and -6 because we subtracted the 6 from both sides. Yep, and those were the only like terms that would combine. So I get x is -1, which we saw right here. X equals positive 3. That is not the full solution.
Yeah, you have to do the y-intercept.
Not the y-intercept, but the y part of the ordered pairs. So I'm going to take this. Does it matter which equation we substitute into?
No.
Nope. Which equation do you want to substitute into? Linear. Sounds good. You're going to get the same answer either way, so it does not matter. Y equals 2 times -1 plus 6. What is 2 times -1? -2 plus 6 is what? 4.
So that's correct.
Yep, so there's one solution, and that's what we saw on our graph. The other one that fell off the graph, I know now why. It's up high. I'm going to substitute in to find that one also. Y equals 2 times 3 plus 6. 2 times 3 is what? 6 plus 6 gives me 12. It barely was off the graph. So there's our other solution. So far, so good?
So if we did the solution first, couldn't we just graph the solution did the solution to the problem on the graph and then did it that way?
You could solve it algebraically first and then graph it and circle them. Yeah. You still need to be able to graph the parabola, graph the line, and identify your solutions. Graphing your parabola, find the middle of your parabola first. -b/2a will always give you the x part. To find the y part, you just plug it back in. You doing okay, Taylor? All right, we've only got about 5 minutes. Does anybody have any quick questions? We did 2 big long ones. Let's see, let me find a fast one for us. Ooh, you said 13? 13 would be fast.
After this, can you like forward, like what is the context of this problem, like the vertex in the context of this problem? Like, can you just...
Yeah, but I do have a video about that one.
Oh,
That one I went over fully in 3rd period.
you did 4 and what?
We did 1, 2, 4, and 5 part B. 13, what does -b/2a tell you? Yep, this tells you the axis of symmetry. This is the x part of the vertex. Axis of symmetry, the x part of the vertex, is what we know from -b/2a. So what does the rest of it tell us then? Close. Remember, quadratic formula helps us find what? Quadratic formula finds what? This finds x-intercepts. So those x-intercepts are always going to be equally spaced from the vertex, from that axis of symmetry. So the -b/2a finds the center, and then this part right here is how much you're going to add and subtract to get to the roots. I think it's number 9 is another real quick short one that I can hit in the last literally 30 seconds. Yep, number 9. The discriminant is the b squared minus 2ac part. This is the part underneath the square root sign. If that's a positive number, can your calculator do it? Yes. So there are 2 x-intercepts.
Has been canceled this afternoon, and students need to take the bus home. Once again, has been canceled.
Because I would add the square root of 17 and I would subtract the square root of 17. 0 is 1 x-intercept. And if it's a negative, can your calculator do that? So what would that mean about the x-intercepts? No x-intercepts. Right. Huh? I have like another copy of this, absolutely. Yep.